أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. So this stream, as I mentioned, is about the neuroscience of memories and decision making. Before we begin, I would like to give a reference of this book, The Mind Within the Brain. This is arguably the best neuroscience book I have ever read about decision making and touching into memories and various systems and hierarchies of motivation and executive function. So first and foremost, I'd like to read few portions of this so you understand where I'm coming from. Now, there's four action selection systems mentioned in this book, as you can see here. Second. Right, so there's four action selection systems, and I am going to focus on deliberation. Okay, this will give you insight into what tonight's stream is about. So, first and foremost, the deliberative system is more flexible. So, this is actually a continuation from the previous sections talking about Pavlovian decision making stimulus response dynamic that exists. And along with this, this allows us to enhance our ability to have an unconditional response. For example, when you walk into a restaurant and you smell some delicious food being cooked, you might salivate and you probably are imagining what that particular type of food is. It might be a type of meat, it might be a type of vegetable, it could be anything that's being cooked. And the unconditioned response in that moment is salvation. Conditioned response is that you want to go and see where the kitchen is, where the tanur in Arabic or tandoor in Urdu, where that is, and see what's cooking. Loosely speaking, right? That's an example of Pavlovian experience. So it's a bit more rigid rather than flexible, as mentioned, and I highly recommend looking into that section. In any case, what I like to focus on is a few portions from this book. So, the deliberative system is more flexible. It can take any action in any situation, but this is key. It is a computationally expensive system. What does computational means? In terms of its calculation and understanding, it's fairly expensive. It requires a lot of cognitive load and of course planning, motivation and intent. And all of this comes from thinking and knowledge. So, with that in mind, in humans, deliberation entails planning, consists of conscious investigation of the future. This is particularly useful for large one time decisions where one cannot try the individual options multiple times to determine the value of each. So, this is a nice example Aaron gives, the author of the book, where he talks about a friend who's looking to get a job at a university. So, do I choose university one or university two? Because each job has its pros and cons, so to speak. Now, it's not simply a case of making a deliberate decision there and then that hey, I'm going to make this decision and I'm going to go with option A, option B. It requires a lot of forethought, future planning, understanding, and seeing where you're looking to move the direction of your career in this particular case. So the process we're going to now focus on, which is very, very tightly related to two concepts I like to touch on today. Number one is episodic future thinking, okay? And number two is the role of the hippocampus, the actual cortical structure that plays a key role when it comes to planning, liberation, navigation, movement, and so on. So, By imagining ourselves in that future event, we can determine whether it is something we want to happen or something we want to avoid. As we will see, both the hippocampus and prefrontal cortex are critically involved in episodic future thinking. So, looking at this particular point here and this one here, it got me thinking, okay, there must be more research around this. I'm quite curious to know what's going on, because what's being stated here is that episodic future thinking is a part of being human, and as it's a part of being human, it requires something which is complex, like planning, motivation, forethought, thinking about the past and imagining the future, or imagining the past and thinking about the future. They are two distinct things, mind you. In any case, it's very important to understand and wrap our head around this concept, right? As we will see moving forward, how this is very key for those of you interested in cognitive science, artificial intelligence, neuropsychology, so on and so forth. So it's a key concept without a doubt. Okay, so a critical question that has plagued psychology for years is, do animals deliberate as well? So deliberate means having the ability to think, one can say critically, but more importantly, think comprehensively. A situation where you're able to have the knowledge and understand the methodology through which you're going to take action towards a goal. Previous stream, we looked at the general state, as in where you are right now, and the desired state or the goal state where you want to be in the future, and how some very basic psychological concepts exist here. So, what we're looking to do essentially is have an idea about how we can understand this in more depth. So, what I like to do is share the papers mentioned here. So, the references given first and foremost is Buckner and Carroll, which I have over here. So, self projection and the brain. You've probably heard of the concept of self projection. This is, in my opinion, grossly misused, because self projection is the idea of seeing yourself in the future within reference of time and the event that's taken place. Okay, so this is what is essentially self projection is in a nutshell. But let's dive right into it. So, Buckner and Carroll, working with Harvard University, Howard and Hughes Medical Institute, Harvard Medical School, and also Massachusetts General Hospital. So, quite a heavy background here, academically speaking, at least. In any case, when thinking about the future or the upcoming actions of another person, we mentally project ourselves into that alternative situation. Accumulating data suggests that envisioning the future, prospection. That's why the phrase prospect is used. If, for example, you have a football team or a sports team, you would say, "Oh, what's the prospect of this player? What are they going to do in the future? What can they do in the future for our team?" This is what prospection is. It's data envisioning the future, what can possibly happen. And this is something schools do not teach students at all. That's why students have zero idea about the future and what they want to do. That's why their memories are poor and their attentions are very, very bad. This idea of prospection, I cannot urge how important it is. Remembering the past and conceiving the viewpoint of others, theory of mind. This is something that's put forward by a researcher called, pardon me, a researcher named Baron Cohen. I think he's a cousin or a distant relative of the Scumrally comedian Sacha Baron Cohen. So his relative came up with a theory of mind. Okay, and possibly some forms of navigation reflect the workings of the same core brain network. So navigation is very important. In chapter 30 of the Quran, that's what Allah speaks about. Go out and view the world. Go out and investigate how we ruined nations before you and understand the blessings of Allah, whether it's something as water we take for granted, or someone who produces a brilliant piece of mathematics, or someone who is able to build a type of technology that makes our life easy. For example, everything we're using now. So, these abilities emerge at a similar age and share a common functional anatomy that includes frontal, which means the front part here, medial temporal, which is the middle temporal, which is around sort of just above the eye towards the right side. So if it's your left ear, we're looking at the top and then the right of that ear. Okay. Medial temporal system that are traditionally associated with planning, episodic memory, and default passive cognitive states. Now, on the previous stream, we looked at how there's a debate between left and right hemisphere. Left is for verbal, right is for something like mathematics, that we are trying to solve a very complex problem. However, there are views and very strong views that both hemispheres intertwine with each other. There's views that no, left is strictly doing the creative stuff and right is strictly doing the complex thinking. In any case, there seems to be harmony at the end of the day, right? And this is what they're trying to say is that association with planning, episodic memory, and default passive cognitive states. So even when, for example, you're asleep or when you're alone, you're thinking about the future or you're imagining the past. Again, these are two different things. Imagining the past, thinking about the future. And there seems to be a correlation between the brain areas that actually to allow us to think about the future and imagine the past. And in the simplest terms, this is called episodic future thinking, which is what we are talking about. So, we speculate, as in the researchers speculate, that these abilities, most often studied as distinct, rely on a common set of processes. So there's a commonality. They're not separate entirely, they're not mutually exclusive. There seems to be a common set between the two, by which past experiences are used adaptively to imagine perspectives and events beyond those that emerge from immediate environment. So as we spoke about navigation, how your immediate environment also affects you, again imagining the future or thinking about the past. Now, it's quite a common thing where if someone's upset or angry for whatever reason, they get up and go for a walk. Of those people who work in hectic environments, whether it's a job or a business or freelancing, they like to have a change of scenery, as they say. I like a change of scene. So for 3 or 4 weeks or so, they go off to, for example, Malaysia or Thailand if you're from England. And if you're from Thailand or Malaysia, you would like to go somewhere like America or maybe Japan or Australia. A change of scene, different culture, different people, different languages. So you have these new experiences, right? So it's quite fascinating how the brain is able to hold not only this information, but also form memories and allow you to think about the future. By the way, we're talking about typical healthy human beings. In any case, in the previous stream, we talked about prefrontal damage, pardon me, frontal lobe damage and prefrontal cortex damage. That, of course, has an effect on language and planning, but that's not our concern. It's just a side point for those interested who wonder, what happens when your brain is damaged. So, this is a nice paper. You can look into this, but what's relevant is this, the history of prospection and the brain. So, this is where the term episodic future thinking seemingly comes from, according to this book by Aaron David Reddish. So, we're going to read this yellow bit and move forward from here. Prospection is the act of thinking about the future and is a prototypical example of self projection. The observation of planning deficits in patients who had frontal lobe lesions led to an understanding the neural basis of prospection, kind of what I mentioned earlier, that studying individuals with severe brain damage or some lesions, which is a technical term for damage to the brain, allowed neuroscientists to study and look into what was happening in the human brain. In the mid 19th century, the case of Phineas Gage. Phineas Gage, it was a man. He had a railway accident. A iron rod went through his skull and just went through his mouth and just outside his jaw was the other end of that particular rod. He survived. However, he had a damaged eye, damaged frontal lobe, and he had issues with memories. He could recognize things, if I'm not mistaken, but can't name them. So, a man whose frontal lobe was damaged during a bizarre accident with the tamping iron revealed that there were structures in the human brain dedicated to the dedicated to the planning and execution of personally and socially suitable behavior. The discovery of neural sorry, someone saying to zoom in a bit. The discovery of neural activity patterns that maintain representations of past stimuli and anticipate future motor actions suggested candidate mechanisms for internal representations that support future oriented behavior. Someone was me. The contemporary concept of prospection, which is covered in this article, has emerged in diverse fields of psychology and neuroscience, including decision making, navigation, memory, social cognition, and animal cognition. Very soon, we'll be discussing a paper that actually shows how animals have the ability to count. Stay tuned for that. Memory of the future, pre experiencing, proscopic, chro- chronesthesia, mental time travel, and imagination. Proscopic chronesthesia, I think that is loss of time or out of touch of time. Prospective memory retrieval can be accomplished. You know, control. Wait, let me just actually look this up. Okay, why is right. Look into that in a second. An idea that emerged at the same time as the concept of prospection is that prospection is spontaneously engaged when people are not otherwise performing directed behaviors. So it seems that planning for the future still appears even when there's no perform when people aren't performing a specific direction. That's that is true, but I think evidence is still unclear because you can give someone a guide and tell them, hey, this is the goal, achieve X, and they will go about their own strategy, their own way of thinking and solving that problem. But what seems to happen is that their behaviors aren't always directed in the way that the researchers desire. And a famous example, you can look this up, is Thorndike's cat box, where responses were changed, i.e., stimulus was changed. Pardon me, the stimulus was changed, therefore, responses of the cat changed. And one angle to be considered is that, okay, though the cat is directed toward escaping this box that Thorndike created, the cat has a hierarchy, as in, if it meows in the box, it's not going to escape the box. But if it hits the lever with its paw, it might open the door. Or if it plays with a rope, it might slowly reveal something that can allow it to escape. So it's the manipulation of the stimulus. So again, when it comes to problem solving, you have many issues that come into play, and you have to solve them when you go towards the end goal. So in cognitive neuroscience, this is called sub goal tasking or goal tracking. So this is essentially where you track a goal that you're looking to achieve, and whilst you're tracking your goals, you might get sidelined. So that's sign tracking. What that means is you take note of those signs that are not relevant, that will not basically help you in achieving your goal. Anyway, in a paper published in 1985, Ingvar anticipated many of the points we discuss here. For more on the concept of prospection related from the projection, see references to 59, 63, 72, 73, 75. Discussion from development animal condition perspective found in Moore, Lemon, and Roberts. Right. So I believe it was this paper that had a diagram of the brain pictures. Right, that's Tolman's rat maze. Mm, should I go into it? I can't speak about the default mode network. Okay, sure. So let's look at the default mode network. We looked at box one. Let's look at box two, and then we'll move forward, inshallah. Box two, the default mode and its relationship to self-projection. Now, a long recognized but puzzling aspect of the brain function is that as one goes from restful state to an active one, engaged cognitive states, such as when solving difficult mental arithmetic problems like mathematics that I mentioned, the total cerebral mean blood flow and oxygen uptake in the blood remain constant. So, not exactly, but loosely a centralist view where measuring electric signals in the brain allows us to understand function of certain cortical structures. It's not always the case where you think something is is to be as you want it to be. So, for example, it seems here that from a restful state to an active one where you're solving a complicated problem, the amount of blood flow and oxygen uptake in the brain remains constant. How do they know? They use various techniques like fMRI and PET scans, and they use something called bold blood oxygen level that allows you to see how much blood in certain cortical structures of the brain. So we'll have a 3D rendition right here, which we'll look into. This is more or less what it is. So this is the temporal aspect here, right here, and then you have the inferior area here. This is frontal, this is dorsals here. Here you have the ventral. So yeah, quite fascinating actually how scientists are able to record this. Anyway, that is in terms of brain physiology, similar energy is devoted to undirected brain processes as it is to brain processes when an individual is engaged in a directed task. That's interesting. Let me repeat that. That is, in terms of brain physiology, similar energy is devoted to undirected brain processes as it is to brain processes when an individual is engaged in a directed task. Okay, this is key. This finding implies that extensive brain activity of some form persists in the absence of immediate task goals. This finding implies that extensive brain activity of some form persists in the absence of immediate task goals. So, what that is, we don't know at the moment. Analysis based on positron emission tomography have confirmed that a highly stereotypic pattern of increased brain activity is adopted during passive task states compared with many forms of active task state. Figure 1 shows this pattern from a combined analysis of 9 separate PET studies. The pattern has been replicated across numerous PET and fMRI studies. The network prominently includes The network prominently includes frontal regions along the midline and network of lateral and medial parietal regions and medial temporal lobe structures. The consistency of this activity pattern in undirected task states, in addition to its metabolic properties, led Marcus, Michel, and colleagues to label it default mode network. The consistency of this activity pattern in indirected task states, in addition to its metabolic properties, led Marcus Rochelle and colleagues to label a default mode network. I actually came across this idea when I was reading a book on the neuroscience of culture, mind, and brain, and they look at how default mode network has been studied to understand planning, organization, and allows neuroscientists to have an idea of how cultures are formed. Sort of stepping into neuroanthropology. Anyway, default mode network is remarkably similar to that adopted during directed abilities that depend on self-projection, including remembering and prospection. This convergence raises the possibility that default modes of cognition are characterized. Sorry, 1 second. Is remarkably similar to the adopted during directed abilities that depend on self-projection, including remembering prospection. This convergence raises the possibility that default modes of cognition are characterized by a shift from perceiving the external world to internal modes of cognition that simulate worlds that are separate from one being directly experienced. Okay, so this convergence coming together raises the possibility that default modes of cognition are characterized by a shift from perspective from perceiving the external world to internal modes of cognition that simulate worlds that are separate from one being directly experienced. So maybe it's a case where what you're experiencing now is not actually the case in terms of reality. So of course there's a question of time, reality, what's real, what's not real, so on and so forth. Right, what's happening here? Oh, right. So brain activity pattern associated with the default mode in the network of regions illustrates those brain regions that are most active when people passively think to themselves as compared with a range of active tasks that demand external attention and decision process. Note that the remarkable similarity between the default regions and those engaged during self-projection, and also the similarity to those regions that are functionally correlated with medial temporal lobe memory system. Hmm, interesting. So again, it's very puzzling to really get to grips with the subtleties that exist. Science can never explain why. It can explain how, but not the why. Right, so yeah, this is a paper I highly recommend those interested to check it out. Next is, I think it's this one I have planned. Shakhtar 2007. Yeah, here we go. Right, so I'll read the abstract and just a few notes as well on this. Remembering the past to imagine the future, the prospective brain. Right. This is they. So these are researchers from grant from U.S. National Institute of Aging, Institute of Mental Health, Howard Hughes Medical. Okay. Harvard. Okay. Right. So abstract. A rapidly growing number of recent studies show that imagining the future depends on much of the same neural machinery that is needed for remembering the past. How many ayahs of the Quran exist that requires a cognitive response naturally when it comes to studying stories of the prophets and messengers, peace be upon them, so that you can look into the past and understand how to prepare for the future, which is, to be exact, the day of judgment, Yawmul Qiyamah. That's the day of judgment. And the past is the past, as in civilizations, peoples, and things that happen. Okay? So, very, very fascinating, to say the least. These findings have led to the concept of the prospective brain, an idea that a crucial function of the brain is used to use stored information, pardon me, is to use stored information to imagine, simulate, and predict possible future events. We suggest that processes such as memory can be productively reconceptualized in the light of ideas. Okay, very fascinating. Right, here we go. Figure 1, the core brain system that mediates past and future thinking. The core brain system that is consistently activated while remembering the past, envisioning the future, and during related forms of mental simulation is illustrated schematically. Prominent components of this network include medial frontal regions, okay, posterior regions, and the medial and lateral parietal cortex extended into the precanus and the retrosplenial cortex. Hmm, I haven't heard retrosplenial in a while. The lateral temporal cortex and the medial temporal lobe. Moreover, regions within this core brain system are functionally correlated with each other and prominently with the hippocampal formation. This core brain system function we suggest that this core brain system functions adaptively to integrate information about relationships and associations from past experiences in order to construct mental simulations about possible future events. Right. So, what is being suggested here in its simplest form is that the core brain system that is activated when we think about the past, remembering the past, and envisioning the future, and during related forms of mental simulation, prominent components of this network. So, they list out medial prefrontal cortex, which is here, right? So, which is around, so just between your eyes here, this sort of region. Then you have posterior regions in the medial lateral parietal cortex. Okay, so the medial and lateral parietal cortex, that is essentially this part, right? So this is the left side of my head, right? So this area just above my ear on the left now, not the right but the left, and just here where the earlobe ends, so around this area. Okay, lateral temporal cortex, pardon me, extending to the precuneus and retrosplenial cortex. So actually goes way back here as well. The lateral temporal cortex and the medial temporal lobe. The lateral temporal cortex, which I just mentioned, which is around here, and the medial temporal lobe. Moreover, regions within this core brain system are functionally correlated with each other and hippocampal formation. Right, so I think we were looking at 34. I didn't look into this, but I guess I will. Right, so from here now we go to Shakhtar 2008. Let's pull this up. So we go from there. Right, so again, it's a similar concept. So the previous research paper's title was Episodic Future Thinking. Pardon me. Remembering the past to imagine the future. Okay. Uh, this is something I did not discuss, but I will. Problem, right. So, episodic simulation of future events, concepts, data, and applications. Again, Howard Mukes, so on. Right. This article focuses on the neural and cognitive processes that support imagining or simulating future events, a topic that has recently emerged in the forefront of cognitive neuroscience. We begin by considering concepts of simulation from a number of areas of psychology and cognitive neuroscience in order to place our use of this term in a broader context. We then review neuroimaging, neuropsychological, and cognitive studies that have examined future event simulation and its relation to episodic memory. This research supports the idea that simulating possible future events depends much of the same neural machinery referred to here as core network as does remembering past events. So just they're just regurgitating what was said in the previous paper. After discussing several theoretical accounts of the data, we consider applications of work on episodic simulation for research concerning clinical populations suffering from anxiety or depression. Finally, we consider the other aspects of future oriented thinking that we think are related to episodic simulation, including planning, prediction, and remembering intentions. These processes together comprise what we have termed the prospective brain, whose primary function is to use past experiences to anticipate future events. Okay, very nice. I've seen this Ingvar person quite a lot. Okay, let's look at this. This is going to be interesting actually. So, regions making up the core network supporting the simulation of events are highlighted in blue, including the medial prefrontal cortex, medial temporal lobe, retrosplenic and posterior cingulate cortex, mentioned earlier, and inferior parietal lobe. The regions making up this core network have been shown to functionally correlate with each other, and in particular, the hippocampus. Peak voxels from relevant contrasts, neuroimaging studies of past future events, are overlaid in the schematic of the core network, including a peak voxel that exhibits one common responses to past and future events. Number two is differential responses to future events relative to past events. So let's start with this column here on the right. These two pictures under title 2, future events only. So relative to past events, thinking about the future, we see these areas matching up. So the blue bits and the red dots here seem to match up. So we have Addis here showing the same recording of the area. And then we have over here where the eyes are the prefrontal region. Again, you have Addis and Okuda agreeing with each other. So that's the frontal lobe, medial temporal lobe, Then you have this is a coronal section, so it looks like the sun. That's how I remember it. Then you have this top bit, so it's chopped off from the bit, and then you have inferior parietal lobe, which are here at the back. This is where the cerebellum is. Again, this is coronal section of medial temporal lobe. It's more or less the same image, and yeah, this showing both past and future events. So common response to past future events. And then retrospinal posterior cingulate, so the ear, as I mentioned, just behind it, above your ear. So yeah, all of these studies seem to agree with each other when it comes to essentially looking at the regions that are initiated or ignited when thinking about the past and imagining the future. So I believe it just goes to show you how important it is to have presence of mind. This is something that I read in a book called 33 Rules of War by Robert Greene. And so his idea is that, you have to have presence of mind before you take action. Very interesting concept. So, yeah, again, another paper really showing how findings overlap and agree with each other. Right, so there's much to look into here. Excuse me. So, last but not least, we will look at A. Tance's paper from the University of somewhere in Canada, I think. Washington. Waterloo. Here we go. Daniela from Waterloo, Christina from Washington. So, this is a nice recap, really, of what we have been talking about. So, we looked at this, looked at this, looked at this. Just quickly double check here. I think there's one more thing I like to discuss. Yeah, it was to do with the hippocampus. So, this is an interesting paper. Thinking about the future as an integral component of human cognition, one that has been claimed to distinguish us from other species. Building on the construct of episodic memory, we introduce the concept of episodic future thinking, a projection of the self into the future to pre experience an event. We argue that episodic future thinking has explanatory value, right, when considering recent work in many areas of psychology, cognitive, social, and personality developmental, clinical, and neuropsychology. Episodic future thinking can serve as a unifying concept connecting aspects of diverse research findings and identifying key questions requiring further reflections and study. Okay, so this is a very nice short paper and various methods of study. So, cognition. Right, let's look into cognition. Right, so prospective memory is defined as how we remember to engage in an intended action at a specific point in the future. Example given, remembering to give a friend a message when we see her. Okay, prospective memory. However, it has been characterized as more than just memory and as intimately related to humans planning the future oriented behaviors. Kliegel, Kliegel have conceptualized prospective memory as involving three distinct processes: developing a plan, remembering the plan, and remembering at some future point to execute the plan. I think this is pretty straightforward. The first of these processes has received little attention in the prospective memory literature, yet could be the component most intimately linked with episodic future thinking. Episodic future thinking might be particularly relevant to how we initially choose or develop the mnemonic that will allow us to remember our intended action in the future. Mnemonic is a device. Yeah, Richard Yogi Balvin. For instance, suppose I must remember to take my medicine immediately upon returning home from work today. I might therefore decide before I leave the house in the morning to place my medicine bottle on the kitchen counter, close to where the glasses are kept. To ensure the effectiveness of this mnemonic, however, it is important that I pre-experience the events I'm likely to engage in when I get home. Pre-experience. Okay, fascinating. If I fail to do this accurately, I might overlook, for example, the fact that because today is Tuesday, when I get home, I will probably go immediately into the living room to watch a favorite television program, going into the kitchen only when it is over. Thus, in this case, a more effective mnemonic would be for me to put my medicine on the coffee table in the living room rather than on the kitchen counter. I think we all do this where we're about to do something and we leave something somewhere where you remember, okay, I'm gonna use it or make use of it later on. This example highlights the distinction between developing a plan that is geared to one's specific actions versus one that is geared to a more script-like routine. Example giving putting medicine near water source. Thus, one avenue for future research involves examining whether prospective memory performance is enhanced more by the development of episodic than script-like mnemonic plans. What working memory we are going to use? Working memory is memory that is used whilst you are consciously solving a problem within the same segment of time. I have no answer for that. I guess I'll look into it. Okay, I'll make a note of that. Okay. Prospective. WCST. Okay, on hold for now. Fascinating. So, judgment and decision making. Obviously, we're going to read into this as well. When people are asked to predict the completion date for a specific project, example, the income tax return, their estimates tend to be overly optimistic. There exist several explanations for this planning fallacy. One is that people tend to base their prediction on only one future plan or scenario and neglect to take into account information about the length of similar events have taken in the past. Another is that people fail to take into account future problems that might interfere with the project's completion date. Hmm. I think we are all victims and people who have experienced that. Not surprisingly, research the planning fallacy the planning fallacy has sought to identify factors that improve prediction accuracy. These methods generally focus on altering the nature of the scenarios that individuals are asked to generate, such as asking participants to envisage both best and worst case project completion scenarios before making their predictions. These types of manipulations have met with mixed results. Moreover, there is no general consensus on why some of these manipulations are effective, whereas others not. Some insight into this problem might be gained by analyzing the content of the scenarios that people generate before making their predictions to determine the extent to which there is evidence for episodic versus semantic future thinking. For instance, in generating a best case scenario, an individual might be more likely to rely on a script of how the event in question, for example, completing an essay, typically unfolds. By contrast, in generating a worst case scenario, an individual might be forced to contemplate particular constraints that are relevant to themselves, only to themselves. Example given, their carpal tunnel injury might flare up again. Mm. Thus, in some cases, people might readily adopt generalized semantic mode of future thinking that could decrease the accuracy of their predictions. By contrast, prediction accuracy might increase in instances in which individuals are motivated to pre experiencing the unfolding of a future plan of events from a personal perspective. What is pre experiencing? It's more or less, I would say, the case of making dua. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. Oh Allah, improve my life in the dunya and in the akhirah. And we don't experience the torment of the fire, right, which is the worst case scenario. This could include, for example, considering the many constraints that are relevant to the self and that will influence how the sequence of events in the plan unfolds. Example given, acknowledging that the completion of an essay would be affected by having to return home on the weekend where it is difficult to work productively. People's tendencies to engage in episodic future thinking and the accuracy with which they make predictions about the future events might also be mediated by the temporal proximity of the target event. Lieberman and Trope have shown, hang on, people's tendency to engage in episodic future thinking and the accuracy with which they make predictions about future events might also be mediated by the temporal people's they make predictions about future events might also be mediated by the temporal proximity of the target event. Might also be mediated by the temporal proximity of the target events. Lieberman and Trope have shown that individuals represent distant future events at a more abstract level than they do immediate future events, even when the event of information that they possess about the event is held constant. Moreover, when planning for future events, people tend to consider time constraints only when these events are in the near future. Yeah, I've definitely been guilty of that. Moreover, when planning for future events, people tend to consider time constraints only when these events are in the future. To our knowledge, temporal proximity of the target event is not a variable that has been considered in planning fallacy research. To our knowledge, temporal proximity of the target event is not a variable that has been considered in planning fallacy. With its manipulation might reveal that people engage in episodic future thinking when the event looms in nearer. So it's all speculative at the moment. Right, let's do goal attainment, and after that we'll briefly look into the hippocampus as well. think hippocampus we can do in another stream because it's fairly dense, so we need another stream for that. So goal attainment. Episodic future thinking might be implicated in Goldwitz's notion of implementation intentions. Okay. Which specify when, where, and how responses leading to goal attainment. Interesting. He stresses the importance of pre-deciding how to implement a future goal rather than simply thinking about the future goal. Studies have shown that the frequency of positive health-related behaviors is increased throughout the formation of implementation intentions. For example, Shearer and Orwell found that participants who had encouraged to commit themselves to when and where they would take a pill each day missed fewer pills than individuals who had only formed the goal to take a pill a day. Given that the formation of implementation intention requires individuals to envisage themselves acting at a particular time and place in the future, given the formation of implementation intentions, future more refinements such as those of okay, so I think this is crucial that we must look into this portion and then we'll call it a night. Okay, Bismillah. The hippocampus is a critical part of the episodic future thinking in humans. In rats, the information represented in hippocampal cells is the first location of the environment. These are known as play cells. From the activity in these cells, we can decode the location represented at a moment in time by the cells. So if a rat were to imagine being at another place in the environment, we should be able to decode that imagination by looking at a set of active hippocampal cells. So essentially looking at cells and what the mice are planning in terms of where they are and what they're about to do and where they're about to go. So neuroscientists claim that looking at this activity, they can decode what they're planning to do. Very, very interesting. So what we'll do, inshallah, next stream, look at thinking and cognition more and step into this in more detail, and I'd like to discuss the hippocampus in much more detail.